if we have time, I'll let you work on those. If not, if you guys are kind of quiet, I'll do those on the video if you want them done. All right, concavity. So definition of concavity is your second derivative. So if your second derivative is positive, then we know that the function is concave up. Second derivative is less than 0. We know the function is concave down. And then we talk about what does that make the graph look like. So if I want to make a graph of f of x, concave up would be if the graph itself is physically smiling. And then concave down for the graph of f of x would be if the graph is frowning. And you want to be really careful and understand that if I break this graph into two pieces, this just if I graph this part, that's still concave up. It doesn't have to be a full, complete smile. It can be half of a smile or half of a frown. Okay, so that not being a full parabola doesn't matter. Let's also talk about, at one point I showed you that you could try using a circle to help you go through concave up and concave down. So we split that circle into quadrants, kind of like a unit circle. It was just a nice way to summarize. So we knew the top half of the circle going this way, because we read a graph from left to right. This is concave down, matching our frowning. So I'm just going to label those concave down. And then these were concave up. And then from there, if I look at the graph here, that graph increased. And this graph here decreased. And then notice I come back to the left side to draw, and that would be decreasing, and then this over here would be increasing. And that's helpful if they ask you to draw a graph. I haven't done that in years, literally maybe over a decade, but you never know. So if you have to actually draw a graph that's concave up or concave down, increasing, decreasing, what you will see is a multiple choice question. And they'll say, which one of these graphs is the graph concave up and decreasing the whole time? And you just have to identify the right one. All right, so that's concavity. Concavity graphically, I'm going to actually add in one more of these. So I did this. So they're exactly the same graph. They're nothing special. And then we're just going to call the intersections right here, the x-intercepts, we're just going to call them negative a and a. So you can just call that negative a, you can call that a. Same thing for the other two. So they're all exactly the same. I'm going to give you a pair of questions to answer. I want to know when f of x is concave up, and I want to know where f of x is concave down. For this graph, I'm going to label it f of x. This graph, I'm going to label it f prime of x. And this last one, I'm going to label it f double prime of x. So graph is the same, questions are the same, labeled the graph differently. Okay, that's all I did. I just changed the label of the graph for each of them. I want you to go through, answer the 3 questions for graph 1, graph 2, and graph 3. Okay, when you're done, check with each other to see if your answers are coming out the same. Because if they're not, then one of you is a little confused on how to do the problem. I'll give you a little time for that. They're not huge graphs. They'll be a little bit more extensive, I think, on the AP. But what should you probably do when asked this type of question? A sign chart. So I'm going to quickly do one. Because the graphs are so basic, I understand you were able to get through without having to build your sign charts for each of them, but I will go through. If I'm asking about concave up and concave down for every single one of them, I'm going to need the second derivative sign chart. So let's go through what words we would use for each of them, and we'll start backwards. So if this is f double prime, but I need f double prime sign chart, what words do we use? Good. And then going backwards, this one I would use slopes, and this one I would use concavity. So we know the words, use them. Okay, that's really, really helpful. So if I'm using y values, I labeled these negative a and a, so I'm going to put those because those are the times that the y values are 0 and my y values are positive, then negative, then positive. My slope is 0 at 0, and my slopes are negative because the graph decreases, then positive. And this one, I'm smiling the whole entire time, so those are all pluses. So hopefully if you have everything up there, then your answers down here should match. Concave up, always. Concave down, never. Concave up from 0 to infinity. Concave down from negative infinity to 0. And then concave up here would be from negative infinity to negative a, union with a to infinity. And then this one would be the in-between, which would be negative a to a. And then if they ask you for a reason, give the definition, because f double prime is positive. Okay? I think that this is also helpful to have on your paper so that they understand you know the definition, but we use slopes to get it, or we use y values to get our sign chart. Sign charts are not accepted as reasoning, so you can't just leave your sign chart there and say that's the reason why. You have to say and state the reason, or write the reason, I should say. All right, so that's concavity graphically. There's a blank page here because right now I can't remember what was there, so I'll skip it for now. Point of inflection, let's talk about that definition. Not on that page. So point of inflection has a two-part definition. Joseph, what's the first part that you know? Four. Yeah, you want to make sure. Baldrick, what was your other part? What changes sign? Yeah, you want to make sure you tell who. Be very clear. Does it matter which way they change signs? No. It will matter for max and min, but it does not matter for this guy. All right, so point of inflection, I just want to be really careful and make sure that you realize it's a two-part definition. Type of question that we get wrong a lot of times is a pretty easy one. Something like that, and I ask you, where are the points of inflection on f of x? So that would be a pretty basic AP question. You may see something similar to this, or maybe the question of if I gave you f prime, it would ask you for max or min. So the concept's very similar. So, nice thing is, we need to know f double prime, and I actually gave you f double prime. That makes the problem a lot easier. Okay? So number one, should we be taking any derivatives? No. Okay, not at all. Janet, why don't I need any derivatives? It's already given. All right. Therefore, first part of the definition is where it's equal to 0 or undefined. So in this case, we have those at 0. Don't forget that guy. That usually gets forgotten. 4 and 1/3. So there are your possibles. And then, what should I make after this? Sign chart. Can someone raise their hand and tell me how I could avoid a sign chart for this one? Boom! Tie. Powers. So what's the power of this x? Odd. So that's a 1 is odd, this one's odd, this one's even. Therefore, which ones would I cross out, if any? Even. Good. So evens don't change sign, which is why this problem is actually really quick and easy. Okay? They won't change sign. All right. Other functions that don't change sign, absolute value actually also doesn't change sign. It's positive all the time. Square roots, e doesn't change sign. All right. Let's think. Point of inflection. All right. Graphically, so graphically speaking, this one you don't have to draw. I'm just going to have you kind of look up at the board and analyze. You're welcome to draw it if you'd like to. I'll just draw something crazy. Let's do. All right, so I got a nice little graph here. I want you to figure out in your minds how many points of inflection do you think this graph has. So go through the graph and physically count how many points of inflection you think the graph has. The graph is f of x. So here's what I'm going to do. You will use your thumbs to tell me if it's concave up or concave down on the parts that I highlight. Okay? So, okay? Okay, curious. Well, I didn't say if you were right or wrong. I just wanted to see what you would say. A lot of people had discussion about this point, which we call, what do we call that? A cusp. They'll tell you if there's a cusp. If it looks like a cusp, they're going to say it's a cusp, okay? So that's a cusp. Just curious. First derivative at that point? Undefined. Therefore, what's the second derivative? Undefined. Does the point exist there? There's no point there? The point does exist. There is a y value that matches that x value. I can physically count how high it is, and that point does not have an open circle, doesn't have a jump, doesn't have anything weird, doesn't have an asymptote. None of that is happening. That point really is a physical, real point. Okay, so therefore f is defined, but these are not. So that's where we start talking about should you cross off values in your sign chart or not. This one I wouldn't cross out in my sign chart. The points really exist. The undefines happen at points that really exist. All right, so this guy was concave up, and then this guy was concave up because it's still smiling, so that is not a point of inflection, which is usually the first one that people discuss. Over here, there is a point of inflection because we went from up to down. Most of you got that one. Most of you saw that that was up. Therefore, you had to count that there had to be something happening in between. I don't know exactly where. Smile, part of a frown, so somewhere in between. Frowning, but then suddenly smiling, so there has to be something in between. Smiling, but then this whole piece, even though I kept stopping here and there, is frowning, therefore somewhere in between. Count. 5. That's a vertical tangent? Does the point exist? Yes, so is defined. Does the derivative exist? No. Does the second derivative exist? No. Why do I know the second derivative does not exist? Because the first doesn't. Okay, good. All right, last piece. Second derivative test. I'm going to go through this in like 3 minutes. Second derivative test, I don't like it. Your test, your AP test will test it very, very specifically. Reason why I don't like it. It is a test to identify max and mins. Identify, but we already know how to identify a max and min. We know max and mins happen, endpoints, we know how to identify those, or inside we do a sign test, right, for our first derivative. You can actually use your second derivative to identify max and mins, but it only works if f prime at a point is 0, and then if it's 0, then we use the second derivative, and this is why they call it the second derivative test. Make a graph of a function that has a horizontal tangent, but is concave up the whole entire time. So make a graph that has a horizontal tangent in it, but is concave up the whole entire time. We agree? Concave up has a horizontal tangent. Therefore, that point, A, has to be here. Therefore, that has to be a minimum. I don't memorize this rule because I'm afraid to memorize it incorrectly, so I always draw concave down, horizontal tangent. I make sure I draw so I verify that I know my rule properly. Real quickly, that's your first derivative test. I want to go through 2 things. When can you not...
We'll hold a town hall meeting today at noon in Ms. Ledain's room, which is B103. Please join us to get involved in planning our spring activities. There's lots to talk about.
So, here's why I don't like the test. This is my reason of why I don't like it. There's restrictions. If you use the first derivative test, which is the sign chart of first derivative, there's no restriction. That will tell you if a max or a min exists all the time. If you use the second derivative test, it's purple. These are the times it won't work. And if you are curious, so how would they test the second derivative test? They're going to ask you on the AP to identify max or mins, but f prime sign chart can't be made. Guarantee you that's how they test it. So when does that happen? A really nice time that it happens, tables, table of values. That's usually one where you won't be able to identify max or min using a sign chart because we don't know what happens in between values. And then there's other ones where f prime is defined as a function. Something like, they'll do weird things like that. They'll give you part of the function, but then the other one they'll call it g of x. And unless you know exactly what g of x is, then you can't make a sign chart. Okay, so those are just little tricks. And I think that's it. And now you may go.